Okay, so we're going to continue to talk about some of these kind of strange compound inequalities, the ones where you have to look at a graph to get the solution. Now, here's a good way to start. I want you to think about this. What's the simplest way to say this corresponds to like a compound inequality? What's the simplest way to say, raise your hand if you were taller than 5 feet 2 or taller than 5 feet 8? That's harder than it needs to be. We can say that more simply. How? Part of that is unnecessary. Part of that statement doesn't really contribute anything. Which one?
Just say the first half.
Just say the first half. Yeah, right? Okay, how come? That's the right answer. This is an or statement, right? For an or statement to be true, how many parts have to be true? Just one, right? So raise your hand if you're taller than 5'2" or taller than 5'8". Does that really contribute anything? If you're taller than 5'2", aren't you already taller than 5'8"? Or sorry, if you're taller than 5'2", if you're taller than 5'2",
5'8". No, 5'8". You're already taller than 5'8".
right? Okay, right. But if you're taller than 5'2", then saying taller than 5'8" doesn't really contribute anything because it's already every height above 5'2". Does that make sense? There, I said it better. Does that make sense? That already means every height bigger than 5'2", and so there's no reason to even say the second part. See what I'm saying? Okay. The second part doesn't contribute anything. Okay. How about this one? This is an and statement. Next one. What's the simplest way to say raise your hand if you're taller than 5'2" and taller than 5'8"? How many parts of an and statement must be true? Both of them. Okay. So again, that's unnecessary. We can make this a lot simpler with one question. Which one? Yeah. Raise your hand if you're taller than 5'8", right? Because both of them have to be true. So there's no sense even saying that first one, because if you're taller than 5'2", and you're taller than 5'8", well, you're already taller than 5'8", right? Everybody see that? Okay, let's take an example, a specific example. What if you're 5'4"? Are you taller than 5 feet 2? Yes. Okay, good. Are you taller than 5 feet 8? No. So are you taller than 5 feet 2 and taller than 5 feet 8? You're not, right? Okay, but if you're 5 feet 9, are you taller than 5 feet 2? Yes. Are you taller than 5 feet 8? Yeah. Okay. So all the heights that are less than 5'8" could never make this statement true because both of them have to be true. So we shouldn't include that red statement at all. It doesn't contribute anything, right? The only heights that are going to be bigger than both 5'2" and 5'8" are heights that are taller than 5 feet 8. So that's all we have to do. That's going to be the solution. That one statement will cause the same people to raise their hand as that complicated statement did in the beginning. Everybody see that? Because the and is included, only the people taller than 5'8" would end up raising their hands. So we could just make that one statement. Okay? So that's similar to something like this guy. Okay, here's one that I think you guys started this one yesterday, is that right? Okay, let's just go through this one together. You worked on it a little bit, right? Let's break this into two parts. I'm going to split this up so we can make this a little bigger. And, so I'm going to make my and symbol. So remember that when we have, a lot of times when we have an and symbol, or when we have an and compound inequality, it'll start off as a triple inequality, something like this. Okay. Is that green in a compound inequality and or? Got and or. It's and. Good. How do you know? Okay, but there's true, but there's something else about this that automatically we recognize this as being an and type inequality. Because okay, good. And it's got how many columns? 3. So it's got 3 parts to it. A combination of 2 inequalities smashed into just 3 columns, right? 3 parts. Everybody see that? Whenever you see those 3-part inequalities, those are always and inequalities. Okay, what would I do to solve that green inequality? Only one thing. What do I have to do? Add 4 to all the parts, all 3 parts of that compound inequality. Good. Okay, so let's do that. If we add 4, okay, there's our solution, right? How do we read that? Do we read it like a book from left to right? Remember how we did this when we have a 3-part one? Where did we start? No, where do you start with this? Did we talk? I thought we talked about this. Maybe I skipped this part. Yeah, there you go. Right, you start in the middle, don't you? If there's a 3-part compound inequality, you always start in the middle. We'd say x is, then we go left first and then we go right. X is greater than 2 and less than 9. Okay, there we get that word and in there. Everybody see that? Okay, that's one kind of inequality. We looked at one like that yesterday, right? This is different. Anytime you have 2 separate inequalities joined with and or, then you always solve them individually. Okay, we just do them one at a time. So we're going to take the 2 separate simple inequalities and just solve those one at a time. How about this first one? What would I do to that first one? What did you guys do yesterday? Got rid of the fractions. We cleared fractions. So what would I distribute in the first one? 4, right? The LCD. There's only one denominator, which is a 4. So that's my LCD. Okay, well, let's do that. Let's distribute a 4. What do I get for my first term? Everybody, what's that? 16. Okay, when we distribute to a fraction, do we divide first or multiply first? Divide. Good. So 4 divided by 4 reduces to what? 1. So we cross out the denominator. We get a 1. 1 times 5 is 5. And then what else do I need to include? An x. Yeah, because there's an x attached. Good. And then finally, how about the other side if I distribute? What do I get? 36? Okay, good. So everybody look at that for a sec. What are the last 2 steps to solve for x in order? Yeah, subtract 16 and then divide by negative 5. Good. Okay, so let's do that. We subtract 16 negative 5x is less than 20, and then we divide by negative 5. Okay, that gives me, cancels out the negative 5s, and I just get an x. Over here I get a negative 4. Is that right? What did I forget to do? Flip the inequality, yeah. Okay, good. Because I'm dividing by a negative, I've got to flip that around. So there's the first solution. X is greater than negative 4, okay? We got to go back and do the other one. Same kind of thing. What would I do here this time? Distribute what? 6, okay. Okay, so what do I do when I multiply by the fraction? What do I do first? Divide, good. 6 divided by 6 reduces to 1. Cancel the denominator. 1 gets multiplied by what's left, which is the numerator. 1 times 1 is 1 times x. 1x is just x, right? How about here? Good. Minus 24 is less than or equal to
Negative 30.
-30. Okay, there's only one step here to get that x by itself. What is it?
Subtract 20, or add 24.
Add 24. Okay, give me thumbs. How we doing? Good? Okay. Okay, so then we get x is less than or equal to -6. And this is an and statement. Okay, so we want to simplify that solution. X is greater than -4 and x is less than -6. It's kind of tricky to think about. Just trying to think about those numbers. Anybody have an answer? How many statements have to be true in an and? Both of them do. Okay. It's tricky, but what makes it really easy is when you graph it. Watch this. If we graph these, the solution just pops out. X is greater than -4. Isn't that an open endpoint at -4, graph to the right? X is less than or equal to -6. That's a closed endpoint at -6, graph to the left. Okay, if it's an and statement, what am I looking for with the blue and the green graphs? Where they overlap or intersect, right? Well, where do they intersect? Where? Nowhere, right? Anybody see that? There's no place where an ant could walk on the number line and be in both the red and the blue regions at the same time. It's impossible. So what's my answer? No solution, yeah. So this one, no solution, or I could just say empty set, right? Those are both options, depending on which option you have on that question. Okay, why don't you go try one of those? Go try that one. Okay, the first one, I think most people push the x's to the right. Doesn't matter though. So they added x to both sides, which means they're going to subtract 10 from both sides. And they got 3x on the right and -9 on the left. They divided by 3. And got that. Agreed? Okay, what's a little better to, that's right, but what's a little better to do here is flip that around so you start the inequality with the x. Right? It's more convenient to put the x on the left side. So we'll just twist that whole thing around and say x is greater than -3. There's the first part of the compound inequality. We solved that one. How about this other one? Well, on this one, wouldn't we just subtract 3 from both sides and subtract x from both sides? Right? So the x's cancel on the right and the 3's cancel on the left. And I get 3x is greater than -3. Everybody agree? Okay, divide by 3. And I get x is greater than -1. Okay, now this is an or statement. So how many of those need to be true at the same time? Only one of them, right? So when I graph these, I want all the places where an ant would be walking on the red graph or on the blue graph. Every place where the ant is walking on either one of those should be included in our solution because it's an or statement, right? Okay, so if we graph this, we're taking all of those. The red graph starts at -3 with an open endpoint. We graph to the right. The blue graph has open endpoint at -1 graph to the right. And are we looking for one or both again with an or statement? Only one, right? What's always going to be bigger, the solution to an or statement or an and statement? Or is going to include more stuff, right? If this were an and statement, we could only include the places where they overlapped or intersected. So we'd start at -1, but because it's an or statement, we start all the way back at -3. How come? Well, because the ant is at -2, for example, the ant is on the red interval. And all we care is that the ant's walking on at least one of them, one or the other, right? Maybe both, that'd be a bonus, but one or the other is required. So our solution then, if I combine these into one purple solution, it looks like that, doesn't it? Doesn't the purple graph include all the places where an ant could be on either red or blue? Okay, so then look at that purple graph, and that's just saying x is greater than -3, which looks like that. Good? Give me 1 to 5. How are we doing? Okay. All right, so we're getting there. This is just for your notes. I'll just put that in the notes on on Google Classroom. Last thing, real simple extension of this. When we talk about unions or intersections of sets, we're doing everything we just did. That's it. Union means or. So a union is going to be every place where both things are happening at the same time. So a union of two sets includes all the parts that show up in either one of the sets. An intersection is like and. That means they both have to be true at the same time. So that includes only the parts of each set that show up in both sets at the same time. Okay? So look at this first one. It gives us a bunch of sets, A, B, C, and D, and it only asks about 2 of them. It wants to know what's the intersection. Union is a U, so flip it, and that becomes an intersection. It wants to know what's the intersection of sets B and C. Okay, well, let's look at set B. B is the set of all x such that x is an odd integer. Well, an easier way to say that would just be all odd integers, right? Make sense? So all the odd integers. What would that look like? What are the odd integers? Throw some out. Like give me a sequence of odd integers. 1, 3, 5, 7, 9, etc., right? And we could extend that back to the negatives. We could do something like this. We could say forever. Infinite number of pieces in that red set. Okay, set C has how many elements? Show me with your fingers, everybody. How many elements are there in set C? Yeah, exactly 4. The numbers 2, 3, 4, and 5. So if I want the intersection of those two sets, what's that going to be?
3 and 5.
3 and 5. How come? Because those are the only 2 elements that are in both at the same time. They have to be in both, right? Okay, so there's, whoops, that's bad color. There's 3 and there's 5. There's 3 and there's 5. That's it. None of the other ones overlap. Okay. How about this guy? A is defined as all the odd integers, the set of all odd integers. B is the set of all even integers. So what's the union of the sets A and B going to be then? Well, what's it going to be? All integers, odd and even, which is every integer, right? That's all there are. So this one's going to be, like if we made these red, let's say, and we made these blue, then the union is going to be something like It's every integer, right? Everybody see that? Okay, what's the intersection of the even integers and the odd integers? Name a number that is both an even integer and an odd integer. There aren't any, right? They're mutually exclusive. Can anybody think of one they think might work? There aren't any. I thought maybe somebody would say 0, but is 0 even or odd? What is it? It's one of them. Which one? It's even, right? How come? Defend your answer. You're right, but logically defend your answer. How come? You got it. What's that mean, though? Okay, because it just fits the pattern, doesn't it? Right? If you add or subtract 2 from an even integer, you have to end up on another even integer. So if I go like from -4 to -2, what would the next one have to be? Well, it has to be 0, doesn't it? Right? So it just fits the pattern. Yeah, so 0 is even. So this one would be the empty set. Or if you want to write it with bracket notation, you could just have a pair of set brackets with nothing in it. Okay? All right, you guys go try one of these, and then we're done. Go try that one. Almost. Okay, so real quick, what'd you get? Let's do the intersection first. What's the intersection of A and B? 5. That's it. How come?
Because it's the only thing that's in both of them.
Yes, it's the only one that is in both, and both would have to be true. 5 is in A and it's in B. That's the only one. So that's the intersection. Because there it is. There and there. Okay, what's the union going to be?
0, 1, 2, 3, 4, 5, 10, 15.
Yeah. How come? Because it's all of the elements that show up at least once. That one shows up once. That one actually shows up twice, but twice is at least once, right?
Yeah.
10, 15, those all get included. 1, 2, 3, 4 all get included because they show up at least once. Would 7 be included? No, because it doesn't show up even once, right? Good? Make sense? Okay? Does this seem like math to you? It is. This is math too. To understand, this is kind of the start of set theory.